Hello and welcome to the next lesson in the Advanced C# course brought to you by your friends here at Tuts Plus. Now in this lesson I'm going to take you into what seems to be a slightly odd feature to be added to the C# language within the C# 4, and that is the dynamic type. And the reason I say that that's a strange feature is because C# at its core is a statically typed language, which means every single type, every single object that you create has a type, and once it has that type, you can't change types throughout your code. It is static. Once it's there, it can't change, and those rules are enforced by the compiler at compile time. So if you try to change types that are incompatible or anything like that, you're going to get a build error. You won't be able to compile. What the dynamic keyword allows you to do is to write more dynamic code that's a little bit more flexible in that way, which seems a little strange as to it probably doesn't necessarily belong in C# for that reason, but really I think what it was added into the language for was so that you could take other dynamically typed languages such as Python or Ruby in the form of IronPython or IronRuby that are targeted to the .NET framework and be able to call from your C# code that is statically typed into dynamic objects within another dynamically typed language. But we're going to get to that in a few moments. So let's go ahead and jump into some code and see what this dynamic keyword really is. So here we are back in Visual Studio. I'm going to go ahead and do the new project dance, and I will select console application and click OK. And so here we are back in our boilerplate code. And so I mentioned before that C# is a statically typed language, which means if I were to do something like this, var test is equal to string. Now at this point the compiler knows that the test variable is of type string, and I can do all of the operations that are associated with a string against this test variable. But what I can't do is change the type, so I can't say test is equal to 5. If I try to build this, the compiler is going to complain and say that you can't implicitly convert type int to string, which you would definitely expect because C# is a statically typed language. This variable was created as a string. It will be a string for its entire scope, for its entire lifetime, and there's nothing we can really do about that. But with the advent of the dynamic keyword, this changes a little bit. So instead of saying var and using implicit typing, I'm going to switch this to the dynamic type or dynamic keyword, and now if I save and build this, it will build just fine. And if you set a breakpoint in here and hit F5, and then go ahead and step through your code, you're going to see that test, its initial value is null, so which makes you think that this is kind of coming from the whole object family of inheritance, and if you were thinking that, you would definitely be right, but its type is dynamic. So if I step over this assignment statement, you're going to see now that its type has changed to dynamic string. But now test is a string, but if I were to execute the next line, text equals 5, you're going to see that the type has changed to dynamic int. So you can see here that there is still a sense of it knows what type it is. The compiler and the runtime know what type these variables are, but allow some dynamic changing of those types throughout your code. So that's a little bit interesting, but at first I really didn't think, well, what could I possibly use this for? Because I don't want to start intermixing a bunch of dynamic code in with my statically typed code, because it's just going to make things very difficult to understand and difficult to read and probably even debug as I go through my code and introduce errors in certain ways. One thing I think that this was definitely added in for was to allow us to write statically typed code within our C# applications to call out to other applications or scripting runtimes, if you will, and execute dynamically typed code from those worlds. So let's take a moment here to see what exactly that looks like. So if I were to erase this code and I were to come over to my references and I were to right click and select Manage NuGet Packages, and make sure that I am selecting the online source. And in my search, I'm going to search for Python. And really what I want to find here is the IronPython package here. So I'm going to go ahead and install that. Now, if you're unfamiliar with Python or IronPython, really you don't need to worry about it, but this is just a quick example that I'd like to do. So what adding that into my project has allowed me to do is now I can create what's called a scripting runtime. So I'm going to create a Python runtime, and that's going to be equal to Python. And now I need to go over this and hit Control period because I want to add using statement for IronPython.hosting, and I want to say Python dot create runtime. So this is going to create a runtime environment that I will be able to execute Python code from within my C# code base. And now that I have this runtime created, I can do something very interesting. I can create a dynamic object, and I'm going to call this a Python file, and I'm going to set this equal to Python runtime dot, and I want to use a file, and I'm going to create a file here in just a moment. Let's just call it test.py. And now what I want to do is so this is going to load the Python script that's found within the test.py file that we're going to create here in a moment into this dynamic type of Python file. And then once I have that, I want to call a method that's found within this Python file, this test.py, from my C# code. So let's go ahead and create this file quickly. So we'll do an add new item, and I'm just going to create a code file. And I'm going to call this, as I named in my C# code, test.py, and I'm just going to throw a couple very quick lines in here. If you don't understand what these are doing, don't really worry about it. It's definitely not within the scope of this class, but I just want to give you an example of how I can write code in a different dynamically typed language such as Python and be able to call it via my C# code. So I've imported my sys. I'm going to define a method or a function here, and I'm going to call this say hello to Python. And so then within here, I'm going to simply put in two print statements. I'm going to say print hello there C#, and I will do another print line, nice to finally chat, since Python is extremely excited to be able to finally talk to C#. Now, one thing I have to do in order for this to happen is, because this is not a recognized file type within my project, I have to change the build action for this to be content, and I'm going to copy to my output directory always, just so that it will copy this file into my bin directory upon build of my code. So now I have some Python code here. I have a method called say hello to Python, and now I can come back into my C# code. I have loaded this test.py file into my C# application dynamically, and now I can call my Python file and I can execute. And as you can see here, there's no IntelliSense for dynamic types because the compiler has no idea. So basically what dynamic is allowing you to do is to bypass all of those compile time checking. So it will assume that whatever you're trying to execute exists, and there will be no checking until the runtime, which is kind of nice and flexible, but at the same time it's kind of dangerous, because if you don't test this thoroughly, and if you happen to mistype something or try to execute something that doesn't really exist within that dynamic runtime, then you're going to get a runtime exception as opposed to a compile time. So you get a little less checking, but a little bit more flexibility. So my method that I want to call here is say hello to Python, and I will save this and I will build, and everything will build successfully. And if I hit Control F5, I missed something here. Scripting, go back to my test.python. Oh, I forgot my semicolon here. Excuse me. Save and build. Come back to my program and do a Control F5. And there we go. Now you can see I get hello there C#, nice to finally chat. So I have been able to call from a statically typed language such as C# into a dynamically typed language such as IronPython. So that's a very cool concept. You can start to get outside of the statically typed boundaries within the C# language to reach out to other languages or other functionality built in other languages. Now that's a pretty cool concept. Not something I use on a regular basis, but I can definitely see where the C# language is going and where .NET is going, and allowing us to interact between a lot of different types of languages. So it's very, very cool. But I do have to say that one of the more interesting things that was introduced by this concept of a dynamic type is the type of expando object. So an expando object is a dynamic type. So if I were to create dynamic and I would say test, and now I could say this is a new expando object, and I will save that, and I will need to do a control period to add in the system.dynamic namespace. And now what expando object allows you to do is, because this is a dynamic type, this test is a dynamic type, it's going to bypass all of the compile time checking of properties that exist on this test object. And what that allows us to do is to use this expando object to be able to dynamically add properties at runtime and assign to these properties whenever we need to. So I can do that by saying test.name is equal to John, as we've done before, and I can say test.age is equal to 35. I can save this, and I can do a console write line of test.name and console write line test.age. Now I can save this, I can build, and I can do a control F5. And this is going to run just as you expected it would, but I have been able to, because this is a dynamic type, I've been able to bypass the compile time checking of these properties in their existence because they don't exist, because test is just a expando object that doesn't necessarily have these properties. But by using the dynamic type, by using this keyword, I'm allowed to add these properties at runtime. So that's a pretty cool trick. Now, if you have ever used ASP.NET MVC applications, you may know that you can start to pass data in between your models and your views and things of that nature. And one of the things you might have come across in your use of that is the concept of a view bag. And a view bag does exactly this. It allows you to use an expando object to dynamically add properties to this view bag that allows you to pass data back and forth in between your models and your views. So that's very, very cool. It allows you a lot of flexibility within a statically typed language such as C# and be able to introduce some dynamic concepts. But I would definitely advise you to be careful with this and not to use it too much, as I mentioned before, it's going to make a lot of things complicated in the debugging of your code and keeping things straight of, at this point, what type is this object, and at this point, what type is that object. So in your day-to-day applications, definitely stick with your normal statically typed processes. But if you need a little bit more dynamic flexibility, you can definitely add this in, and it will work just fine for you. So I hope you find some benefit in that, and I will see you in the next lesson.